Okay, so we had a little problem with the snub cube.
They weren't zone constructible.
Yeah, so we misunderstood, unfortunately, in the zone geometry thing. It said there were 13 of them, and 11 you could make out of zone tool, and 2 you couldn't. And unfortunately,
the snub cube was one of those.
the snub cube was one that you couldn't build. So, but we tried, right?
Yep. Yeah.
And we struggled and struggled, and then we looked it up and found the problem. But let's go back to the first one we built. What's that? What was that shape called, do you remember?
Wasn't this like icosahedron?
Okay, yeah, so move the rhomb bicosahedron out of the way. So bring that into the middle now. Let's see if we can count the number of faces, edges, and vertices on this, okay?
Alright, so, well, we can count the faces by counting the pentagons and then the triangles.
Let's see. Well, how many pentagons? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 pentagons.
Okay.
And triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So there's 20. There were 12 pentagons, and now there's 20 triangles, so that's 32 shapes.
Okay, so 32 faces on this one.
Yeah.
Yep.
Okay.
So
now that's right, let's count the edges now. Or would you rather count the vertices
Let's
next?
count the vertices.
Alright.
Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Okay, so 30 vertices. How else could we have counted those vertices?
Well, you could count this row here, the ring around there, the middle ring, and this ring, and then that.
Okay, but that's kind of the same way. That's counting them up and down. Is there any other totally different way we could have counted the vertices?
Count down. You could count 1/2 of it and then multiply it by 2.
Okay. Is there any other way?
Well, you could look at the pentagons.
Okay. What would that
you
tell
have 12 pentagons.
Okay.
And each one of them has 5 vertices.
But you're overcounting.
Yeah.
You're overcounting.
And each pentagon shares a vertice with exactly one other pentagon.
So
like this one.
Every vertice is being overcounted twice.
Okay.
So then you divide by 2.
All right. So what would that get you to?
That would get you to 30.
Explain that calculation.
Well, it was 12 pentagons times 5 vertices divided by 2.
Okay. Very good. So we got 32 faces, 30 vertices.
And now
how are we gonna count the edges?
Well, we could count them top to bottom again.
Well, you could count the number of pentagons again.
Okay.
Well, and then each pentagon doesn't share. They don't share edges.
So the pentagons don't share edges. So that means you should have 60 edges.
Interesting.
Cool.
Do you get all of the edges?
Yeah, because the pentagons and the triangles overlap.
Yeah.
Huh.
You don't have to count the triangles.
Cool. Now, so we got 32 faces, 30 edges.
And 60.
Sorry, 60 edges.
And 30 face. 30 vertices.
30 vertices.
32 faces.
32 faces.
60 edges.
Okay. And do you remember Eulers Formula? Do you remember how that works?
Vertices, wasn't it vertices minus edges plus faces? Well.
Okay, so let's do that. And what does that supposed to equal?
I think that's supposed to equal 2.
All right. So how many vertices did we have?
So we had 30 vertices.
30 vertices.
Minus edges. So there were 60.
Minus 60 edges. So we're at minus 30 now.
Plus 32 faces.
Equals?
2.
Hey, how about that?
Cool.
Pretty cool.
Yep.
Do you want to try it for that one too?
It might be big.
Alright, let's give it a shot. We'll do that on a new video.
Alright.